morning, everybody. My name is Amrita R, and today my topic is execution of complete instruction. Fundamental concepts. Processor fetches one instruction at a time and perform the operation specified. Now we must know that processor reads only one instruction at a time and performs whatever the operation that particular instruction specifies. Next, instructions are fetched from successive memory locations until a branch or a jump instruction is encountered. All instructions are sequential. If first instruction is located at 1000th position, the next instruction will be located at 1004th location because we'll assume that our system is 4-byte computer. But these instructions are successive only if a branch or a jump instruction is not encountered. Next, processor keeps track of the address of the memory location containing the next instruction to be fetched using program counter. Now the processor always knows what will be the next instruction that has to be executed, and that particular instruction will be stored in program counter, which is PC, and the current instruction which is executing will be stored in IR, which is instruction register. Executing an instruction. Fetch the contents of the memory location pointed to by the PC. This means that the program counter must have some address, and from that address we are fetching some content. The contents of this location are loaded into IR, and this is fetch phase. Now this particular phase is called as fetch phase, and the contents of the program counter is now loaded into instruction register, which is IR. Assuming that the memory is byte addressable, increment the contents of the PC by 4. Now to execute the next instruction, the program counter has to be incremented by 4, and it will give the next instruction that has to be executed. So we are doing PC plus 4, and that is again stored in the PC. Carry out the actions specified by the instruction in the IR. This step is saying that whatever the content of the instruction register is, that has to be executed, and this we call as execution phase. Now we will see the single bus organization of data path inside a processor. This means how, with the help of single bus processor, the data is transferred among the components of the processor. We already know some of the components such as program counter. The content of the PC is sent to MAR, which is memory address register, and then using address lines and memory bus, that particular content is transferred into memory data register. Now this memory data register holds particular data which is present in this address. And then this particular data is transferred into instruction. Now the contents of the PC is an MDR, and that is then transferred to IR, which is instruction register. And whatever we have seen from PC to IR is considered to be fetch cycle. So whatever the address was present in the PC is now present in the instruction register. So this is the way from PC to MAR, and with the help of address lines and memory bus, it is transferred to MDR, and then later on it is transferred to IR. Now here in IR, we will have the content of the instruction, And with the help of instruction coder and control logic, that instruction will be decoded, and later on using this bus we will see how that particular instruction will be executed. Now these things which we are seeing are general purpose register starting from R0 to Rn-1. So the mux is getting two inputs, that is either constant 4 or either 1, and it is giving one output which is A. And then we have another input which is B, and both these inputs are given to ALU. So with the help of mux we are getting one input and the other one we are getting from B. And then we have ALU. Here we have some of the operations, add, subtract, XOR, and many other things. We have two inputs and Z is the output, and this is the temporary storage which we are using to store whatever the result we get from the ALU. And after that, whatever the result is stored in Z can travel through the bus to any of the register which is destined. This is how single bus organization of the data path inside a processor looks like. Let us see how this works with an example. Execution of complete cycle. The example we have taken is add R3, R4. Now these brackets for R3 are important. This is important because these brackets are telling that R3 is in indirect addressing mode. We'll consider an example, add R3, R1. Now these brackets for R3 are important because they are telling that R3 is in indirect addressing. It means R1 is having some value, but R3 is having, it is storing some address, and on that address we have the value which we need. It means we have to travel to that address to fetch the value which we need, and that will be added with R1. So this form of addressing is called as indirect addressing, and that is why we use brackets here. Steps include fetch the instruction, set the first operand, the contents of memory location pointed by R3. It means that we need to read the value that is stored in the address location that is pointed by R3. And after that, we are performing addition. Since we already have R1, which stores a direct value, we can perform the addition after we fetch the value into R3. So now after that, stores the result into R1. So after performing addition, whatever the result it gives, that is stored into R1. Now we will see this execution of complete cycle with the help of diagram and control sequence. Now suppose that PC has 1000. So this 1000 is given out. That is why it is written as PC out, and then it is given to MAR, which is MAR in memory address register. Now from MAR, using address lines and memory bus, that will be transferred to MDR, and the content of that particular address is read from the MDR. Now let us hold at this point. Now once this instruction has been passed to MDR, the content of the PC has to be updated to the next instruction. For that, whatever the current address was there from the PC, that is given to B input. And then we have select 4, which means the multiplexer is selecting 4 as the input, and that is given to A. And then ALU now has A and B as the inputs. A stores 4 and B stores 1000. Now ALU performs add operation on these two inputs, and it gives output as 1004, and that output is stored in Z temporarily, and then Z out takes place, and the value is taken out from Z and stored in the PC, and that is why it is PC in. So now the content of PC will be updated to 1004. And after all these operations are completed, it moves to the next instruction. Now the new value for PC is 1004 and it will give this value to MAR and then to MDR and it gives to instruction register. Hence it is MDR out and IR in. IR is connected to instruction decoder and control logic. This unit will know what is the instruction because it decodes the instruction and will know what has to be done next. This is representing the address. At address 1000, there is an instruction which tells add R3 and R1. This will be decoded with the help of this control unit. It will see that it has to add R3 and R1. But R3 is in indirect address and R1 is in direct address. So the value of R1 will be here and we have R1 to be storing 10. For R3, it has to move to address register, that is MAR, and from that address with the help of memory bus, the data will be read by MDR. Then the value will be given to MDR. See the control sequence. Now R1 is having value 10 and R3 out will happen. R3 will give the address as 1008. At 1008th address, the value stored is 20 and this particular value is read and now this particular value 20 is read and now 20 is stored in MDR. Now R1 out will happen. Addition has to be performed. R1 has value as 10 and that particular thing is passed to B as an input and Yn is taking place for MDR which gives the value R3 and Yn is taking place for MDR which gives R3 value. R3 value is here in mux and then it is given as an input for A, as an input for ALU. R3 value is stored in mux and that is given to A and B has 10. Now both operands are here, A and B. And the operation that has to be performed is add. Now control unit will tell to perform add operation, so ALU performs addition on A and B. And the result is stored in Z. That is what our control sequence is saying. Zn means it is storing the value of A and B temporarily. Z out takes place and we are storing again the ultimate result into R1. This completes the execution of the instruction add R3, R1. So this completes the execution of complete instruction. Thank you.